This lesson is vertex form of a quadratic function. So our learning target is I can write quadratics in vertex form. Alright, so you should already be familiar with standard form. Standard form is when you have ax squared plus bx plus c equals 0. So that's when the part with the x squared goes first, and then the part with the x, and then the constant. And it's always going to equal 0. So standard form helps when you want to find like the y-intercept, or if you just want to look at if the function is opening upwards or down. Vertex form you use when you want to look at the vertex. So remember, vertex means the maximum or minimum. So whenever I say vertex, I'm talking about the max or the min. So here's vertex form. It's a x minus h squared plus k equals 0. So these are representing the exact same quadratic. There's just different forms that you'll look at sometimes, and you just need to know that they are equivalent to each other, so they mean the same thing. Okay. So hk, when you're talking about h right here and k right here, that represents the vertex of the parabola. And then let me use a different color. That's the same color. When I'm talking about the x right here, and I didn't put a y, but sometimes there's a y right here, that represents a point on the parabola, so any point. Alright, and then the little a value, that just controls the width of the parabola and whether it opens up or down. So if a is positive, the parabola opens up like a smiley face. If a is negative, the parabola, oh, I have a spelling mistake. The parabola opens downward like a frowning face. Okay, so we're going to sketch these parabolas and we're going to state the vertex. So what I want you to do is I want you to take number 1 and either using a TI-84 graphing calculator or using desmos.com/calculator, I want you to sketch this graph. So if you're not familiar, you're going to go to desmos.com/calculator. It's actually so much easier than using an actual graphing calculator in your hand, I promise. So go to desmos.com/calculator and type that in, and I'm going to screenshot what I get and show you. So pause the video in 1, 2, 3. Okay, so if you're having trouble with Desmos, you can always click this little keyboard icon, and that's where you can get like your little squared button and all that stuff. The thing I love about Desmos is that if I want to find where the vertex is, all I got to do is click this and it gives it to me automatically. So if we were in class, I would show you how to do it on your graphing calculators, but for right now, we're just going to use Desmos and stick with it because it's so easy. Alright, so I'm going to go back to that first one. Alright. Okay, so when I say sketch, you just draw a little picture, and then the vertex is either the maximum or minimum, and all you had to do was click the little button. Okay, so now if you'll do the same thing for 2, 3, and 4, just sketch them and then state the vertex, and if you're using desmos.com, just click on it. So I'm not going to sketch them, I'm just going to state them, but I want you to sketch them in your notes. So pause the video in 1, 2, 3. Okay, so the first one we said was 3, 2. The second one, you should get 1, negative 2. Number 3 is negative 3, negative 1. And number 4 is negative 1, 3. Okay, so vertex form, remember, it looks like this. It's a x minus h squared plus k. So the number beside x, change it to its opposite sign. That's your x coordinate of your vertex. So notice in the formula, you had negative 3. If I change negative 3 to its opposite, I get positive 3. And then the k value is just at the very end, and that's your y coordinate of the vertex. So here, I'm gonna highlight it again. So the opposite of negative 1 is positive 1. That's my x coordinate. The last number is my y coordinate. Same thing with these. The opposite in here is my x coordinate. The last number is my y coordinate. The opposite number in the parentheses is my x coordinate. the last number is my y coordinate. So that's the whole idea behind vertex form. If you had the equation, you don't even need to graph it because you can figure out what the vertex is instantly. And that's why you have these different forms. Okay, so now we're going to look at writing the equation of a quadratic formula if you're given the vertex and a point on the graph. Okay, so the instructions are at the left. You can write them down. You can pause the video if you need more time. But it's pretty easy. First thing we're going to do is identify h and k. So remember, h and k are the x and y value of your vertex. And then x and y are the point on the parabola. So we've done number 1. We've identified hk and xy. Number 2, we're going to plug these into vertex form. So here's vertex form. Okay, so we have a x minus h squared plus k equals y. Okay, so my h is right here, so I'm going to replace that with a 2. My k is 1, so I'm going to replace that with a 1. My x is 1, so I'm going to replace that with a 1. And my y is 4. So I have plugged these in. Number 3, simplify inside the parentheses and then apply the exponent. So if I do 1 minus 2, I get negative 1. And now I'm going to apply the exponent. A negative 1 squared is 1. Alright. And then we're going to rewrite the part containing a so the coefficient is in front of a. So like, for instance, where we have a equals a times 1, we would write that as 1a. Okay. No need to really write 1a because remember, anytime you don't have a number in front of a variable, it's an understood. So I'm going to rewrite this. It's just a plus 1 equals 4. Okay. Number 5 says we're going to solve for a. So if I want to get rid of this plus 1, I would subtract 1 from both sides. So a actually equals 3. And now we're going to write the equation of the quadratic with all of it put in. So a, h, and k we're going to put back into the formula. So we found a. It was 3. X is always going to stay x. If you remember, h at the very beginning was 2. So 2. We always have a squared. Plus, if you remember, the k at the very beginning was 1. So plus 1. And it's going to equal y. So x and y are always going to stay x and y. But you need to have a value for a, for h, and for k. Alright, that's a little confusing, I know. Okay, we're going to do the same thing with this one. Alright, so here's my h, my k, my x, and my y. I'm going to write the vertex form down, and then I'm going to start plugging in appropriately. So x minus a negative 1 squared plus 1 equals, let me go ahead and replace x and y with their values. Okay, so I'm going to go ahead and do the stuff in the parentheses. 0 minus a negative 1 is a positive 1. 1 squared is 1. Oh, I keep doing that, I'm sorry. A times 1 is just a. And, ooh, not a plus sign. And now to get rid of the plus 1, I'm going to subtract 1. So a actually equals 2. And I'm going to put it all back together. So 2x, I'm going to do plus 1 squared plus 1. Alright, so remember, whatever the x coordinate of the vertex is, when you write it in the parentheses, it's going to be the opposite sign. That's why I have the plus 1 there. Okay, I want you to try this one, so pause the video in 1, 2, 3. So identified h, k, x, y. Now I'm going to plug them in. I'm going to simplify the parentheses. I'm going to apply the exponent. I'm going to solve for a by getting rid of the minus 2. And now I'm going to put it all back together. So I have negative 2. X plus 2 squared minus 2. Remember, it's a plus 2 because the x-coordinate of the vertex becomes the opposite when you put it inside the parentheses. Alright, so hopefully you got that right. If that doesn't make sense, send me a message. Okay, so let's look at some word problems. So I'm gonna pause the video just a minute. Well, I'm gonna let you read it. Okay, so there's a lot going on in this problem. The fish population in a certain part of the ocean, as a function of the water's temperature, is modeled by blah, blah, blah. Okay, so we are talking about two different things. We're talking about fish population, and we're talking about water's temperature. Alright, so x is always referred to as the independent variable. So x is going to be our temperature. Okay, and that leaves y being the dependent variable as our fish population. So anytime you have two variables in a function, and they're not using y, they're using p of x for population, same thing. Anytime you have two variables, you need to look in the problem for like two different things that you're comparing. So we're comparing temperature and we're comparing fish population. And we're given this quadratic, and the quadratic is actually in vertex form. So I'm going to write it out a little bit easier. Maybe you can pick up on it that it's on vertex form. Okay, so maybe you see it now. Okay, so what you're saying in this formula is that my a is -2, my h value is 9, and remember h and x are like the same thing pretty much. So h, I'm saying the temp is 9. Let me use a third color. So my K is 200. So if the temperature is 9, that means the fish population is the 200. Okay, so what is the maximum number of fish? So we're already in vertex form, so it's already telling us what the maximum is. So the maximum number of fish is 200. If that doesn't make sense just reading it like that, what I want you to do is take that function in blue and I want you to graph it in Desmos right now. So pause the video and graph it in 1, 2, 3. Alright, so I just took a screenshot of my Desmos graph, and you can always zoom out and in using these little things. You can use the mouse cursor or whatever you need to do, but zoom until you can see the maximum, and then you can touch the maximum and it'll tell you. So remember, the first coordinate is always x, the second coordinate is always y, so x equals 9, y equals 200. And remember that x is representing temperature, so that means that the 200 is the fish population. And that's the highest the graph ever goes, so that's the maximum fish population. So two ways to look at it. You can look at the formula that they give you, the algebraic model, the quadratic equation, whatever you want to call it. Or you could graph it and look at the maximum. There's really no need to graph it unless it just makes you feel better, because it's already in vertex form and it's already going to tell you the maximum. Okay, let's look at another one. So, I love Post Malone. Post Malone has 100 meters of fencing to build a rectangular garden. The garden's area in square meters as a function of the garden's width x is modeled by a of x equals negative x minus 25 squared plus 625. So, it's already given you the vertex. You just need to interpret it. So what I want you to do is I want you to see if you can figure out what x represents and what a of x represents. And if you get confused, this a probably corresponds to a letter that starts with a word that starts with a. So pause the video and try it in 1, 2, 3. Okay, so if you can read, it says that x is width, and that means A must be the garden's area. And anytime you see something like this is really your y coordinate. Okay, so it's already in vertex form. So now we know this is going to be the x value of my vertex. And that means the last number by itself is the y value of my vertex. So this is x and this is y. So if the width is 25, then the maximum area possible is 625. So if it's in vertex form and you're talking about a word problem and it's asking you about maximum, all you gotta do is look at the coordinates. If it's not in vertex form, you can always graph it, or you can put it in vertex form. Okay, so now let me show you some other problems. So, I don't know if we're going to take the Math 2 final exam, but this question has been on there before. It looks really tricky at first, but what I want you to pay attention to is this right here. This looks an awful lot like this formula. And it is. It's the vertex form. They're just using different letters. So sometimes they'll do that just to make sure you understand that you're still talking about the vertex form, you just have different placeholders for numbers. Okay, so here's my equation. And it says it's rewritten in this form. And we know that that form is vertex form. So what I'm going to do is I'm going to graph the equation in red. But remember from previous math courses, you can't graph an equation until it's equal to 0. So if I needed to get rid of minus 12, I would add 12 to both sides. So 2x squared minus 5x plus 12 equals 0. I want you to graph this in Desmos, and I want you to find the vertex. So do that in 1, 2, 3. Okay, so I took a screenshot of Desmos, hopefully you can see it, and I just clicked on the vertex. I got the vertex was at 1.25, comma, 8.875. So remember, usually I would call this one H and K, but for some reason they're using P and Q. But we're going to do the exact same thing. So we're just going to put my X coordinate in the parentheses like we always have. And then we're going to put the y coordinate at the very end. Okay, so all they've done is they've taken this formula that was in standard form, they've rewritten it into vertex form, which we have done just by finding the vertex. And the only thing they want to know is what is the value of Q. Q is the last number, so it's right here. 8.875. Now obviously the answer choices are in fractions. Just put those in your calculator and see which one gives you 8.875. So try that and pause the video in 1, 2, 3. And the answer is B, because when I put B into my calculator, I get 8.875, which matches up. Okay, this was on the North Carolina final exam a couple years ago, and 70% of students in North Carolina that were taking Math 2 missed this question. Alright, so I want you to do another one. We're going to take this, let's set it equal to 0, so we need to move the 53 over. Alright, so I want you to graph this. I want you to graph it and find the vertex, and then we're going to plug the vertex in and we're going to answer the questions. So graph it in 1, 2, 3. Okay, so you should get that the vertex is 4, 5, which means I would put 4 right here and 5 right here, and then the rest just stays the same. Okay, and then the last thing I want to know is what are the values of P and Q. So P is right here, so P equals 4, and then Q is at the very end, Q equals 5. Alright, so you've done it. Not much to do. You can try the examples on Haiku, and if you need any help, you can message me. I know that was kind of a long video, so sorry, but that was vertex form. Remember that vertex form helps you find the vertex and answer word problems quickly. I don't know. Alright, bye.